For Pythagorean theorem, in a right triangle, the sum of the squares of the measures of the legs equals to the square of the measure of the hypotenuse. So in this case, if you recognize this is going to be your hypotenuse, and the two legs are going to be A and B. If we're talking about the formula, that is going to be squares of legs, sum of squares of legs, it means A square plus B square. It is going to be equal to C square, which is hypotenuse square. So for example number 1, you're going to have your hypotenuse as 14 and the other two legs are 7 and x. If you're using the Pythagorean theorem, you're going to have x square plus 7 square equals 14 square. So you're going to have here is x square plus 49 equals 14 square, and 14 square is 196. You're going to subtract 49 on both sides and you're going to get x square equals 147. To solve for x, you're going to use the opposite. It means you're going to take a square root on both sides. So when you take square root on both sides, here you're going to have is normally is plus or minus, but you're going to only take plus sign, so you don't have to write plus or minus. Square and square root cancel. You're going to get x equals, break 147, so always reduce it into small radical if it's possible. And this is going to be 49 times 3, because 49 times 3 is 147, so that's going to be 49 times 3. When you take the square root of 49, that's 7 outside, and inside you remain with 3. So x equals 7 square root 3. So that's going to be 8 square, which is hypotenuse square, equals x square plus 4 square. That's 8 square is 64, 4 square is 16. Subtract 16 on both sides. X square is 48. Take square root on both sides. You got 48. Break it as 16 times 3. Square root of 16 is 4. So that's going to be x equals 4 square root of 3. For number 3, you can see in this big triangle, there are two triangles hidden in it. And we have to take the help of one of the triangles. So let's say if you're going to do this triangle, you're going to make sure you have all the sides for this triangle. This whole number on the bottom, whole side is 14. You can have this one broken into 7 and 7 because it's a perpendicular bisector. So both of them is 7 and 7. And if you apply the Pythagorean theorem in one of the triangle, you're going to have is 8 square equals x square plus 7 square. Here you're going to have is 64 equals x square plus 49. Subtract 49 on both sides. X square will be equals 15. And then take the square root on both sides. X equals square root of 15. For the special triangle, this is the first one, that is 90, 45, 45. So this is 90 and the 45, 45. How the sides are related to each other when these triangles are given in this form. That's what you need to remember. So for example, if this is 45, 45, 90, this leg, both the legs are same. So both the legs are same. And for the hypotenuse will be square root 2 times x. So x times square root 2 or square root 2 times x. Whereas if you're talking about 90, 30, 60, 90, obviously this looks like a 30-degree and this looks like 60. How these sides are related? The opposite of 30 has to be the smallest side and it should be x. Opposite of 60 is the biggest than 30 side, that's going to be x times square root 3. And obviously the side that is in front of 90-degree, that is hypotenuse, that's the biggest side and that's going to be 2 times x. How these sides are related to each other is this: if this is x, the smallest side, the other side of that would be x times square root 3, and the hypotenuse, which is bigger side, is double of the smallest, so 2x.